Hi everyone, my name is Rennie Kendrick, and my project compared two brain regions, the parietal cortex and ventral temporal cortex, or VTC. And I compared these brain regions because they represent different features of information we encounter in our daily lives. For example, if we were to encounter this teddy bear, the VTC region in our brains would represent more directly observable features, such as its color or maybe its size, whereas the parietal cortex would represent more abstract features, such as its category or your level of familiarity. And in this project, I used previous findings about the type of information these brain regions represent to answer the question, do memory representations contain conceptual or perceptual information? I hypothesized that memories would contain conceptual information. To answer this question, I analyzed fMRI data from a study where participants were viewing objects and scenes in one phase, the perception phase, and then recalling objects and scenes with no visual input in the other phase, the recall phase. I trained an algorithm called a multi-voxel pattern classifier to look at a participant's neural data and determine the category of the stimulus they were viewing or recalling, depending on the phase of the study. And I trained this algorithm 4 very specific ways, which allowed me to answer my question. I'll focus on the first 2 ways I trained the classifier, which pertains to the first set of results. In one training scheme, I trained the classifier on perception data and tested on perception data. And in the other, I trained the classifier on recall data and tested on recall data in each of the brain regions we are interested in. This allowed me to examine how accurately information could be decoded in each brain region, both when participants are encoding stimuli at perception and when they are reactivating the memories of those stimuli at recall. I hypothesized that at perception, where there's visual information, neural representations would be more easily decoded in VTC, a region that represents visual information. However, I also hypothesized that memories contain primarily conceptual information, in which case at recall, category would be decoded more easily in parietal cortex, given that parietal cortex represents more conceptual features. My results partially confirm this hypothesis. On the graph, we have classifier accuracy on the y-axis. VTC is represented by the purple bars and parietal cortex by blue. The group of bars on the left represents training and testing on perception data, and we can see that the classifier did have higher accuracy in VTC than in parietal cortex. But in the group of bars on the right representing recall data, there is no longer a difference between the brain regions. However, I did not see that parietal cortex had higher accuracy at recall, as predicted. Now I'll focus on the other 2 training schemes for the second set of results. I will refer to this scheme as cross-task training because I trained the classifier on one task, let's say perception, and then tested on the other task, let's say recall. High classification accuracy under this scheme would indicate that neural representations are similar at perception and recall. Based on my hypothesis that memories contain more conceptual features, I predicted that neural representations would be more similar in parietal cortex across phases than in VTC, given that the parietal cortex is known to represent conceptual features. That is, I expect classification accuracy under this scheme to be higher in parietal cortex. Looking at the results with classifier accuracy again on the y-axis, I did not confirm this hypothesis. The purple bars are always higher than the blue, indicating that neural representations in VTC are more similar across phases and demonstrating that, in fact, perceptual information is represented in memory in addition to conceptual information. Finally, as a follow-up analysis, I was interested in seeing how the degree of similarity of representations linked to behavior in each of these brain regions. I used results from an old new memory recognition test participants completed after being scanned. In these figures, we have classifier accuracy on the y-axis, my proxy for similarity of representations, and corrected hit rate on the y-axis, reflecting the participants' memory performance. I saw a significant correlation between similarity of representations and memory performance in parietal cortex only, indicating that although similarity of representations overall may be lower in parietal cortex compared to VTC, it directly relates to memory performance, whereas in VTC it does not. In conclusion, these findings demonstrate that reactivated memories contain both conceptual and perceptual information. However, in parietal cortex, the degree of similarity of neural representations at perception and recall, what is sometimes called fidelity, actually relates to participants' memory performance. This demonstrates that although memories may contain both perceptual and conceptual features, reactivation of conceptual features is more useful for differentiating between pieces of information we encounter.